At the Amherst kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, luckily there were no big news stories that happened over the weekend politically to talk about, and we can distract ourselves with things that are of larger magnitude importance in the astronomical scale of things than the small and silly things that we humans do on this planet. One of the things is finding a black hole that's just the right size.
Well, or you can think of it as a political commentary that we would rather be in a black hole than in the current situation.
That's true. And that the news cycle has been drawn into a black hole of what happened over the weekend. So, black holes.
Right. So, we have talked a lot about black holes. There are two types that are usually common and we talk about. One are sort of like star-sized black holes. And they form when large stars that are bigger than our sun, when they die. And so you have these black holes in our galaxy as well, in other galaxies as well, which you would expect because we know large stars exist. And we know when they die, they end up as a black hole. Just as a clarification, our sun is never going to be a black hole. It's going to end up in a state which is called a white dwarf. So we know these are called stellar mass black holes. These are like, a few times the mass of our sun to maybe 100 times you can go, or a little bit more. Then, my favorite black holes.
Mine too.
Then there are black holes at the centers of galaxies. And there is a black hole in the center of our own galaxy, Milky Way. It's about 4 million times the mass of our sun. So you can already see there is a big distinction. Individual star-sized black holes, a few times the mass of our sun. At the centers of galaxies, now we are talking about million times the mass of our sun, or tens of billion times. The black hole at the center of our own galaxy is relatively small, because you can have black holes that are billion times the mass of our sun. For example, the image that we saw of the shadow of the event horizon a few years ago was at the center of a galaxy, and that black hole is about 1 billion times the mass of our sun. So, these two types we knew.
We didn't say the name of the second type, which is the coolest part of it.
Supermassive black hole. I agree, actually. That is the coolest part about it. No, and if you've seen the movie Interstellar, there the black hole was of a supermassive black hole type. So, you have these two different types, small and supermassive, really big. So the question was, well, as astronomers like to do, wait a minute, what about something in between? And they said, we'll come up with a cool name, intermediate mass black holes.
Yeah, well, that's all right name, I guess.
So and again, the formation mechanism of these black holes, the stellar mass ones, the star-sized ones, and the supermassive black holes are different. Stellar-sized ones, when the star implodes or explodes, it turns into a black hole. Supermassive black holes, we are getting closer to the understanding of them, but we still really don't know if galaxies form around these black holes, and these big black holes are seeds, or at the centers of these galaxies, the density of stars is so high that it forms a lot of black holes and they merge to become big. So the question was, well, if we can find something in between, perhaps that can help our understanding as well. But do they exist? And astronomers have been looking for black holes on the scale of about 10,000 mass of our sun-sized black holes. And so far, there were tantalizing clues, but there was no conclusive evidence where we can say, aha, this is it, up until very recently.
Where did they find this intermediate-sized black hole?
Well, so there is a globular cluster. So you have, around our galaxy as well, and around other galaxies as well, you have these blobs of clusters, which are called globular cluster.
Clusters of what?
Clusters of stars. And I would have called them globular clusters, but astronomers call it globular clusters because they look like globs. And these
What's the difference between a glob and a blob? Nobody knows. That's the mystery of astronomy.
That's the next mystery. So these clusters this is when you are forming star forming regions like Orion, but bigger star forming regions. You can form a lot of stars together, and then they stay together as well in a glob or a blob. This would be tricky, and these you can have 100,000 to 1,000,000 stars in these globular clusters. Now they are densely packed, like. The nearest star to us, Proxima Centauri, or the Alpha, or the Centauri star system, that is about 4 light years away. Well, in a globular cluster, this space of 4 light years would be full of stars. So there are a lot more stars. The density is very high, and so astronomers thought that perhaps if you are trying to look for these intermediate mass black holes, you look for at the centers of these globular clusters. Maybe we will find them. Because it's hard to find black holes because they don't emit light. You have to figure out some other way, either if something gas is going around it and it forms an accretion disk.
Or like the Amherst trash day where it takes your recycling and just dumps it into the black hole itself.
And where it goes, nobody knows.
No, it goes to the MRF, I think, in Amherst. We did a tour about that. You can listen to the podcast from Earth Day where we went there. Yeah. Oh, no, wait, Amherst doesn't go there. They have their own way of doing things. I forgot.
Thank you. So that is one way you can form globular clusters. But there is one other interesting way. And that is that if you have a small galaxy, a dwarf galaxy, and you can strip out its stars, then you can be left off with the center, which is very dense. And that may mimic, in some sense, a globular cluster. And so astronomers thought, well, if you have black holes at the centers of large galaxies, maybe we can find it in some sort of like these smaller galaxies, and maybe if there is a globular cluster which is close by, we can find it in there. And that's what astronomers did. There is a globular cluster in our own galaxy. It is called Omega Centauri. It is visible from the southern hemisphere, actually to the naked eye. If you are in a dark spot, you can see it. I haven't seen it yet, but you can see it sort of like the size of a full moon. It's a cluster of stars. It's an unusual globular cluster because it's very big.
You're going to the southern hemisphere pretty soon, though, right?
I am. I'm going to Cape Town for International Astronomical Union's General Assembly. I'm going there in early August. Hopefully, we can do a segment from there.
That would be really cool.
I don't know if from Cape Town it would be visible or not. Probably not. But nevertheless, so Omega Centauri, it's unusual because it's a much bigger globular cluster than usual. It has about 10 million stars. And just to give you an idea, 10 million stars are compressed in about 75 light years. So you are
10 million. And for context, our sun is 9 light minutes away.
That's right. And the nearest star system is about 4 light years away. The radius, so this would be around 150 light years across this cluster. Mm-hmm. And in 150 light years, normally you would expect about 100 stars, 150 stars. Here you have 10 million stars. So that's a lot of stars.
Yeah.
But also, this particular globular cluster, for various reasons, we know it has properties that don't match up with other globular clusters in our galaxy. In our galaxy, we have about 150 of those. And again, other galaxies have those too. But these are generally old objects. But this Omega Centauri is a little bit younger. But I should also mention, which I thought was cool, that Omega Centauri was actually cataloged by Ptolemy in his Almagest about 2,000 years ago. So anyway, so this cluster has been known. At that time, they didn't know what that was, but now we know that it's a globular cluster. And astronomers had been suspicious that there is a cluster, that there is maybe a black hole in the middle. Astronomers also look for black holes at the centers of globular clusters because there is so many stars and they are gravitationally interacting with each other that there's something happens which is called mass segregation, meaning to say the bigger objects fall towards the center and the lighter objects get a kick and they sort of like fluff up the globular cluster. So if you have a big black hole, they expected it to be going to the center of these globular clusters. But again, so far, there had been no confirmation of these intermediate black holes at the centers of globular clusters, except that in Omega Centauri, astronomers had been looking at it for over 20 years using Hubble Space Telescope. One of the indications, or one of the things that people were asking was, if there is a black hole, a big black hole at the center, then there should be stars close to it, which are at very high speeds, because of black hole's mass. Black hole can speed up those stars, and those stars are still there rather than being shot out from the globular cluster. Meaning to say, if you find high-speed stars at the center, their speed is bigger than the escape velocity of the cluster, they shouldn't be there. Or at least by coincidence, maybe one star is there, but not a few. And in this particular case of Omega Centauri, Hubble Space Telescope observed the motion of stars. So now you are looking at stars moving. You can actually see them over a period of time, over 20 years. And they notice that there are 7 stars there that actually have speeds that are greater than the escape velocity of the cluster, and yet they are part of the cluster and right towards the center. So they think that is, and I should just mention, that this star cluster is around 17,000 light years away. So not too far, if you think about it. This is within our own galaxy. And so that suggests that there is a black hole in the middle. And by measuring the speed of the stars and the way they are moving around, they can figure out what is the expected mass of the central object, which we cannot see. So we can only infer from these stars.
Because we can't see a black hole, because light cannot escape from a black hole, but all the evidence is pointing towards this globular cluster, 17,000 light years away, that we found our first not stellar mass black hole, a small one, not supermassive black hole as we have in the center of our galaxy, but one right in the middle.
And
it's like an economy car-sized black hole.
And they found that this black hole has a mass of around 8,200 times the mass of our sun.
So not like a couple hundred times the mass of our sun, like a stellar mass black hole, and not like a million or billion times the size of our sun, like a supermassive black hole, like a stellar mass black hole. Or a million billion for like a supermassive black hole.
And I should also mention there is a cool thing about it, that one of the reasons why astronomers have so many images of the center of Omega Centauri, or the center of that region, is because Hubble Space Telescope was actually using that cluster for calibrations. So they were actually taking just a lot of pictures. Okay, well, does it look the same? Does it look the same? And so they had a lot of pictures of this particular cluster, which over 20 years, you can actually map those out and see if there are stars that you can see their motion, their positions change a little. This is a very hard thing to measure, especially because you are looking at the center of a cluster. But Hubble Space Telescope has the ability to look at individual stars. And they actually mapped 1.4 million stars. I mean, it's just mind-boggling if you think about it. That they mapped about 1.4 million stars, in which they found the positions of 7 stars change in a way that suggested they are moving much faster than they should if they were part of the cluster, or their escape velocity. They should have escaped from the galaxy, from the cluster, because they were moving at high speeds. But because they were not, those 7 stars suggest that there is a intermediate mass black hole at the center of Omega Centauri.
We can use this as a metaphor that if the news cycle of this past weekend is sucking you in, you can let it suck you in a supermassive way, which might be too much and too depressing. You can let it suck you in a stellar mass way, which may be not enough. But maybe somewhere in the middle, you let yourself get sucked into these news stories. But keep in mind that there's a big, vast universe out there, and none of this is going to matter by the time whatever is happening in that globular cluster right now finally reaches the Earth.
And that even when you look at Omega Centauri, you are looking at millions of stars. And so, and it has taken 17,000 years for the light to get to us. Our small little problems on 4-year cycles, those are actually much less than the cosmic scale.